Hi everyone, this is Fahad Mirza and I welcome you to the channel. So far, if we have to provide context to our large language models, we have to do either fine tuning or we have to do retrieval augmented generation or RAG. Especially when it comes to providing the context of your local documents or your enterprise documents to all these large language models. The easiest way of doing so is through retrieval augmented generation pipeline, but now we have something called as CAG or Cache Augmented Generation. I'm always a bit skeptical about these acronyms which really try to mimic what we have already, but this project seems quite interesting. In this video, not only I'm going to explain in very simple words what exactly is this CAG or Cache Augmented Generation, plus how it is different from RAG, and then I will also show you how you can test it out. So let's get started. Before I do that, let me give a huge shout out to Master Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on range of GPUs, so do check them out. Okay, so let's go back to this CAG and see what exactly this is. At very high level, what it does is it tries to mitigate one issue with the RAG. And that issue is of latency or sometimes wrong answers. Well, wrong answers is something which you would still get with CAG, but that is, I think, not the main point of this project. In my opinion, what this project really holds value is where it comes to latency. Because what it is trying to do, it is trying to preload all the documents what is needed in terms of context into large language models context. This could be a game changer if implemented correctly because it is going to eliminate and remove the need for real-time retrieval. Because if you have a preloaded knowledge, that is going to improve the latency a lot. And if your domain is fixed, if your data is fixed, and you know what sort of queries will be there and what sort of information is required, then this could be real fast. The only issue is that most of the use cases in real world are not finite. They are open-ended, so that is where I think that this might struggle. But before we start nitpicking into this project, let's try to understand how exactly it is working. So, CAG is using long context LLMs with preloaded documents and pre-computed memory called as key value cache. This primarily eliminates reliance on external data fetches that enables instant and contextually accurate answers without errors. So instead of dynamically retrieving documents, CAG preloads all required knowledge into the model's context. And then documents are encoded into a key value cache that stores inference states and eliminates the need for lookups. So these queries then have direct access to preloaded information that ensures faster response and that bypasses or eliminates retrieval mechanism. And as all the context is already preloaded, there is not really any risk or minimal risk of retrieval errors or incomplete data. So as I said, there are few preconditions of it. You must know all the relevant documents which are required. So all the relevant documents must be curated and pre-processed to fit within the LLM's context window. So it means that you have to have a long context large language model. Then your documents must be transformed into a pre-computed KV cache that stores inference states. And that is where I think that this project does well in terms of the tests which they have provided, and I will shortly show you. And this KV cache is then stored in memory or disk and reused during inference that eliminates repeated processing. And the user queries leverage the preloaded cache ensures instant responses. So if you look at this diagram, this is a comparison of traditional RAG and CAG. The upper section here shows the RAG pipeline that includes real-time retrieval and reference text input during inference, whereas the lower section shows CAG approach which preloads the KV cache and that removes the retrieval step and reference text input at inference. And they have a lot of detail in their paper about the technicalities and some of the maths too. So if you're interested, then you can check it out. They have also shown some of the benchmarking on the test on squad and hotpot question answer dataset with varying reference text length if you are interested in delving more. I still believe that they could have added bit more information, but just they have just 5 pages of this paper. It's not a huge read, but I think they would do well to include more information around it. So that is the whole idea behind CAG. Now, there are a few things which we need to be aware of that caching context can avoid retrieval and reduce latency for sure, but we have to have the documents and queries they are which are limited in scope, because this is not going to scale in any case if the queries are unbounded, and because otherwise it will spill over to the disk in terms of cache limitations. Also, we have to know the interaction pattern with the LLM, because if it is irregular and it is unpredicted, I don't think so this is going to fly. And that is a huge setbacks. So also, I believe that this is good enough for maybe local single use where everything is finite, but where a large scale LLM is implemented, I don't think so this is going to work. So if you want to test it out by yourself, let me show you the steps as how you can do that. Let me take you to my local system where I'm running this Ubuntu system. And this is my GPU card NVIDIA RTX A6000 with 48 GB of VRAM. Let me create a virtual environment with Conda. And now let me git clone the repo. That is done. Let's install all the prerequisites from the root of the repo. And there are a lot of things which it installs, so it takes around 5 to 6 minutes. So you just have to be patient there. Everything is installed. Next up, you need to download the datasets on which you want to test this CAG on. And that is again going to take a bit of a time because these datasets could be huge. And that is done, took around a couple of minutes. Let's clear the screen. Next up, we need to set the environment. Now you can set that environment. What it means is that what model you want to use. For example, you can use Google's API key, you can go with OpenAI's API key, or you can go with the Hugging Face inference token. So I already have the token which I got for free from Hugging Face, and then this is a free token, so there could be throttling, so this might not complete, but I can at least show you how this works. One thing you need to be aware of, if you are using OpenAI's API key, it's a paid option. So, and platform.openai.com, others are also paid option, but they have more credits and less throttling. So if you really want to do it end to end, then in broad maybe, then go with OpenAI's, but that could be expensive anyway. So I'm just going to set my Hugging Face inference token here, which you can also get from huggingface.co by logging in from your profile. And then let me save and exit from here. Okay, so my key is set. Now in order to run it, all you need to do is to run this command, which primarily uses this kvcache.py from the root of this repo. Here kvcache provides the file, whatever you want to generate. And then this is a dataset Scott train which we are using. You can go with hotpot qa-train if you like. And then we are matching the similarity on bird score, which is a standard. And from Hugging Face, we are using this Llama 3.1 8 billion instruct model. And then we are specifying just a random seed. I'm not specifying this, put it to 0. There are few others which you can set, but I'm not setting others. But if you look here, we are also setting max knowledge 5. That is, it selects how many documents in data set. And then similarly max paragraph, how many paragraphs you want to do. And then the questions. So for example, you can go with 5 if you like, if you just want to do a very low sample. So let me run it. So let's wait for it. Okay, so I would need to install this bits and bytes. This, it means that it was not in their requirement. So let me quickly do bits and bytes. That shouldn't take too long. That is done. And now let me run that again. And there you go. It has started downloading this model locally, which is good. I thought it would be using the API, but that is even better. So let's wait for it to finish and then we will check that result kvcache.txt where it is going to put the results of this CAG. And it has started running the test. So you see it has loaded the models here. This is a KV length, which is just around 31407. And then this is how long it took. Just prepared all the cache with this data set. And then these are some of the Q&A which are happening here. And then it is giving the similarity set score and also the cache and the generation time. And it will go on and on and on and check with it. Thankfully, we are using local model, so I don't have to worry about the cost or about the throttling here. And I'm not sure how long this is going to take, so let's see. Let's wait for it to proceed a bit further. And if you are wondering how much VRAM do you need in order to run it, it is the same as you would need for Llama 3.18 billion, which is just over 20 gig of VRAM you would need. So it is still running. I think it is going to complete a lot of questions. So in order to save time, I just confined it to 80 questions instead of 1000, and you see that it took this much time and around 19 seconds, and then this was the average similarity. So the cache hit seems quite good, and then this was a cache time, which is very good, and this is how much it took. Now, if you want to compare it with something like RAG, you can also do that. They also have provided the script, which is something like that, which is using the same sort of configuration which we used with the CAG. So you see, this is the index which it is using. You can use BM25 or you could use OpenAI, and then again you can use dataset for Squad or Hotpot, and the rest of it is similar. And then it is going to give you the similar sort of results, but without cache, of course. So it is running at the moment, loading the model again, the same Llama 3.18 billion one. And then it is working on all the questions. Again, I have just given it 80 questions. And you can ignore this warning. This is just about the semantic mask and stuff. And this is the result of that RAG script. And I think for 81, it has just shown this, which doesn't look that bad, but still I think in terms of a static data set with the static queries, the cache hits are quite good and quite fast, I would say. But anyway, if you want to test it out on your own data set, feel free to do so. I will drop the link to their GitHub repo in video's description. Play around with it. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps. Thank you for watching.